So the linear constant coefficient differential equations, also called LCCDE. Suppose equation is input output relationship. In a equation has given like y of n, the output is y of n minus 2 times n minus 1 equal to 4 x of n. At the instance n, we want to take the output. This output depends on the previous output value n minus 1 and also depend at the instance input. So this type of input output relationship equations are called recursive systems. The systems are called the recursive systems. Here the output y of n at the n instance equal to 2 times y of n minus 1 means the previous output 2 times plus 4 times at the instance of x n the input 4 times input. So this is the equation. So now from here n is replaced by n minus 1 means at the previous output. If we want to take the previous output means y of n minus 1, then n is replaced by n minus 1. Every n is replaced by n minus 1 means n, this n also be replaced by n minus 1 means this n minus 1 will be n minus 2. 2 times y of n minus 2, 4 times x of n minus 1. So if we put this y of n minus 1 in these equations, in these earlier equations, here y of n minus 1, 2 times y of n minus 1, we replace this y of n minus 1 by this equation. Then we get y of n equal to 4 times y of n minus 2 plus 8 times x of n minus 1 plus 4 times x of n. Again we will take y of n minus 2. Again we will get some value. Then we will replace the n minus 2 to these equations. Again we replace this n minus 1 to this equation. Then this input output relationship become a long, very long equations where the at the n instance output depends on very past, very previous output value also. So now the question is this type of recursive system is LTI or not? So to check LTI or not, first we have to check additivity and the homogeneous scaling. So for additivity, suppose we feed suppose we feed x1 to the systems as input, then we get output y of n, y1n in the equation. Similarly y1n minus 2 times y1n minus 1 equal to 4 times x1n. Now we feed x2n as input, we get y2n as output, and the equation like y2n minus 2 times y2n minus 1 equal to 4 times x2n. Now we feed xn as input, where xn equal to a times x1n plus b times x2n. Now the output y of n, if it satisfy a times for x1n y1 output, similarly b times for x2n y2n output. If the output also satisfy this equation, then we can say this system is LTI system. Actually this expression, this proof is very large and time taking process. So if we take y of n equal to 2 times y of n minus 1 equal to 4 times x of n. Now y of n replaced, now x of n is replaced by 4a times x1n plus 4b times x2n. Now this by taking a as a common and 4x1n, then 4x1n is replaced by this value. Again taking b as a common and 4x2n also replaced by this value. Now we get these equations, and from by simplicity equations we get these equations. And again we have to satisfy the value of n minus 1 also. In this process you can also prove it by taking n minus 1 and replace the value of n minus 1 here. You can also prove it that this equation satisfy linearity satisfied, and when we take time invariant n minus n replaced by minus n, then you can also prove this time invariant. So this type of system is LTI systems. Next, the implementation of the system is y of n minus 2 times y of n minus 1 equal to 4 times x of n, and the y of n equal to minus 2 times y of n minus 1, taking right hand side, we get 4 times x of n plus 2 times y of n minus 1. Now for implementation purpose, put x of n here, by putting x of n, but in the equation it is 4x of n, so multiply, this is a multiplier by 4x of n we get, and by then we get output y of n, but we have to delay by 1, so so now it is fitted to a delay. Now we get y of n minus 1, and this y of n minus 1 is multiplied by 2, and this is fitted to a summer, so we get y of n, and this y of n equal to 4 times x of n plus 2 times y of n minus 1. This is our equations. So the most important thing is that an important class of LTI systems are those for whom the input-output relationship is given. This is an important important factor, that summation of k equal to 0 to n a k y of n minus k must be equal to summation of m equal to 0 to m bm x of n minus m. Here bm is the constant term at the input side, x of n minus 1 input side, ak is the constant term at the output side, and when the input output can be equal, then we can say this is an LTI system. In our case, for these equations also can be satisfied that when we at the output side, when we take k equal to 0, means a naught y of n, for the y of n we have a naught value is 1, so the a naught value is 1, so the a naught value is 1, but when k equal to 1 means a1 y of n minus 1, for y of n minus 1 coefficient is minus 2, so a1 value is minus 2, and a3 a4 all the values is 0. In case, so similarly in case of input, if we put m equal to 0, b naught x of n, for x of n the coefficient is 4, means b naught value is 4, and b1 b2 b3 all the values are 0. So the main factor is when the input output relationship is like that, then we can say that this system obviously LTI system.